This is our Python for machine learning class, lecture 20. And we will be winding up by next class. So in this class, I will show you some more capabilities of Pandas library and probably some of the data sets that people use. And then maybe in next Wednesday, I think the next class will be next Wednesday. I will be winding up after giving an overview of all the ideas that we have learned. And there are small things left out here and there, which I think maybe I will cover up. I will announce a series test in the next class, the dates and timings. And as I mentioned, there will be 2 series tests. So I will work out the modalities and let you know in the next class. Okay. So we will straight away move to Pandas. So we have been looking at Pandas library in the last lecture. Today we will move a little bit forward and find out how the Pandas library can be used effectively in data analytics and machine learning. So how the Pandas library provides an easy way to manipulate data and deal with unknown or unforeseen data or issues with a non existent data, or so there are several issues that can occur while you collect data sets. So that we will see how to manipulate. So let us go to our next slide. Okay. Yeah. Okay. So let me open the slides here. So I will give a review of the previous class. I think some of you did not attend it. So Pandas library is a scientific library written in Python, and its main purpose is to analyze and manipulate 2D data. There are 2 data types, core components in Pandas, series and data frames. So these 2 figures will show how a data frame and a series are related. A data frame or a series is a set of data or set of one-dimensional, single-dimensional data. You can see it on the left side. So when you put together several series, you will get a data frame. So in here in the diagram that I have displayed, there is a data set called apples, and another series called oranges. There are 2 series, apples and oranges. So I will explain what exactly this data set means. So this is the structure of your series and data frames. Now, if you should import the Pandas library as I have marked here. So Pandas library, you should be imported to your program, and maybe I will run it. I will run this Pandas. Okay, I think run. Okay, then we will look at. So this all we have already seen in the last class. I will again review it. We look at how you will create data frames or data sets from scratch. Now, here is an example. In this example, say we are running a shop. We are running a shop, fruit shop, and we are selling 2 kinds of fruits, apples and oranges. So let us look at this figure here. See on the right side of the figure. No, don't you forget about the series. You look at the data frames, data frame part here. So here, the first customer comes in. He orders 3 apples and 0 oranges. The second customer comes in, again, he orders 2 apples and 3 oranges. The third one orders only oranges only, and the fourth customer is ordering 1 apple and 2 oranges. So this is a typical scenario from a shop. So we have limited our hypothetical shop to selling only two things, only 2 fruits, and see the columns here, or the columns shown here are purchases for each fruit. See, for example, the values under apple are the number of apples purchased by various customers. And the same thing applies for your oranges also. Now, let us see how we will capture this into a data frame. So look at the Python code that I have written here. Here, if you see here, I have a dictionary. I have a dictionary named data. See data. And dictionary, this is as a key value pair. This is the key. These are the values. So against apple, the key apple, we have these values. See 2, 3, 1. We have collected it. And against the oranges, or against oranges, we have the other values given in the thing. Okay, 1 second. I think I forgot to switch off this light here, so that you will have a better visibility. Okay. Yeah. Okay. Now, so we have created this dictionary data. And now we created data frame purchasers. So we have only just 4 purchasers or 4 customers. So this we have created into a data frame using this particular command, or our purchases equal to PD. PD has been imported earlier. Data frame data. So when if you type it, if you run this, you will get say a data frame like this. See, now you see customer 0, customer 1, customer 2, customer 3. So the purchases are this way. So this kind of a 2-dimensional data structure is called a data frame. So most of our data collected in real life, whether it is customer data, patient data, or some student data, so most of them will have this kind of a format. So there will be different customers or students which are 0, 1, 2, numbered 0, 1, 2, n, and there are values like apples and oranges for against each customer. So this kind of a structure is a data frame. Okay. Now I think now there is one issue here. If we have the customers or named as 0, 1, 2, 3, etc. Now in practice, it will be nice if you can give names to each of the rows. So we have names already for the columns. Columns are known against some items, but rows here we have only 0, 1, 2. These are the indexes of this row. These are the index for each of the customers. 0, 1, 2, customer 0, customer 1. So that is not a good idea. So what we can do is we can actually make something like this. See, if you see this here. So what I've done is purchases. Slightly here. Purchases equal to PD data frame from our original data that I created. Then for index, that is against 0, 1, 2, 3, the row numbers, I am going to give some names. So this, if you see this, so this will create a better idea or better data frame with which is more intuitive. For example, If I do this index thing like this and print this, if you see my data frame has changed like this. See, the customer named Ram has 1 apple, 3 oranges. Second customer, here's a name. He has this many objects written. So they see this is how a typical data frame is made. I think we studied this in the last lecture also. So I'm just reviewing so that we can have a better idea. Now you can locate a particular customer this way. So this is in many places you will need. The shop owner should know whether this particular customer Anup, whether he has purchased something. So he can print it like this: loc purchasers dot location of Anup. So that will print the entire purchases that he has made. So that will be printing. I can access a row in this manner. So of course you can access a row using that numbers also. So the indexing, what the indexing I have given here is just an alias for 0, 1, 2, 3, etc. You can always access it using that indices. Okay. So that is what we saw in the last lecture. Now, secondly, we looked at CSV files or comma separated variable files. CSV files are text files which contain data. So so if you look at the same thing, here in a terminal. Let me open up a terminal somewhere here. There's the terminal. So there's no terminal here. There's a terminal somewhere here. There's no scene here in my Python. Oh, it's not here. You can actually, okay, I will show how this is done. So this file, this particular folder, I think you can see the folder. In this particular folder, I have this purchases.cv file, purchases.csv. Let us examine it. Let us examine the purchases.csv file. Let's see what's happening. Yeah. Here you see how that CSV file is organized. I will make it a little bigger. That particular file, that CSV file, is organized in this manner. There are see the first value or the top row which indicates your category items. That is the first value. And secondly, and there are only 2 categories, and the first thing is missing. That I think if you put a name or something like that, that will also come there. Okay. And say RAM 30. In this manner, we have created this particular text file. From this text file, you can read the thing. Same thing you can read. See, come back to this one. I'm reading this one. This also we saw in the last class. So instead of creating this from a dictionary data type, you can actually create. You can actually read this from this values from a comma separated variable. So comma separated means see each field. See this particular customer. This is the first value, second value. Each value is separated by a comma. And then say the index. You can say like so if you're reading from a comma separated variable in this manner, say this is why this is how this was read, because your first column there was nothing in the first column. See, if you look here in the actual data, see here it was something, it was missing. There was nothing here. So that's the first thing. There is just a comma, then apples oranges. So because this was missing, when I read it read as unnamed 0. the unnamed zeroth value, it read. So that is why this is coming. But in practice, you need to make this particular first column or names to be an index. You can make that but in a very simple manner. You can actually rewrite the above line in this manner. See, you pd.read underscore csv purchases.csv. This is a file, and you make the first column zero as the index column. So that will be treated not as data but as labels for each of the column. In this case, you will get something like this. If you make it an index column this manner, you will get something like this. So that is how you read data from CSV. This also we saw in the last lecture. Now, in general, people keep data in CSV files or in some kind of JSON files or in databases. So these are the main three sources from where you get data. We will look at JSON. JSON is called JavaScript object notation. It's a file format in which you keep structured data like the one I have shown. See, this JSON files are extensively used. So they provide a method of keeping things structured. So I will show a JSON file here, JSON file of the same data. So here I have this JSON file here. Let me open it up and see how it looks like. See, the JSON file for the above data is organized in this manner. So this is a very common data organization. If you see, this thing is slightly different from your CSV file. See, CSV file, we listed everything one by one. And here, what I do is we do some kind of a column-wise representation. See, for example, the first column was Apple. So let us look at the first column here. So our first column was apples. So here. So that is being represented in the JSON file as, say here, this is the top column value in the JSON file. This is a notation. This is an object notation. See, the JSON thing starts here. See, this is the this starts here and this ends here. And each line each thing is represented in a kind of curly brackets. So here, see, apples was purchased by Ram, number 3, Rahim, 2, Lily, 0, Anoop, 1. Then again comes oranges. So this is the because of the representation, it should have ideally come here, but our Jupyter is displaying it wrongly. You see, actually, you can go for some software which properly displays a JSON file. So this way, you have a JSON file, which is very common in practice. You can capture data to your Python data frames or Pandas data frame. So this is how I do that. See, this is very simple. If you have a JSON file, you can straight away read it this way. So this will automatically come into our data structure, Pandas data structure, and the labels will be taken care of automatically. So many practical applications, people keep data as JSON files. So JSON and CSV are two common file formats that with which people store data. Okay, so you can actually do other things like structured SQL files also possible. See, you can take data from a SQL database or something like MongoDB or MariaDB or the SQLite or PostgreSQL. There are many database servers available. I think MongoDB is different. See, you can capture data from these databases also. I'm not detailing it. Those who are interested, they can look at some internet resources. There are many tutorials which shows you how to capture data from SQL files. Now, we will look at a bigger data. So in the last lecture, we looked at something called Iris dataset. Iris dataset contained only just 150 data of 3 categories. And today, we will look at something called IMDb data, movie dataset. So, see, this is a very standard dataset people use. This is that IMDb. I hope people know what is IMDb. There should be at least somebody who doesn't know. You can just have a search on internet for IMDb. So this is where people rate and review movies. It's an online database of movie ratings. Okay, let me come back. So there is a dataset called IMDb movie dataset. This one contains information regarding 1,000 movies released between 2004 and 2014. So let us examine the content of that dataset. So I have that dataset here, and so I will post it to your module also. This is a very standard dataset. People run competitions. People run things on many things, many programs or things on such datasets. So here I have a CSV file which contains 1,000 entries. Each entry. So let us look at the top entry. Top entry is the column values: rank, title, who is the director, actor, year of. See what is the rating, how many votes people did, how much revenue it got, what is, I don't know what is Metascore. That should be some score from movie industry. So for each, so 1,000 such movies people have so collected this particular data. So for example, you might be knowing some of these movies. So for example, the first line, I will explain what it is. See, this is the name of the movie, that Guardians of the Galaxy. So it's a genre, or its rank is 1. That is the highest grossing movie, the best performing movie within that 2004 to 14, within the 10-year span. So this is the rank of the movie, and then this is the name, and this is a genre, which category it is. This is an animation, science fiction movie. And this is a summary of that movie, short summary of the movie. Then who is the director, who are the actors, and so on and so on. This is our typical data. We have such 1,000 values with us. So you say, I think if you go to the IMDb, you can download bigger data sets like yearly or half yearly or over a span of 20 years or so. So this particular data set, IMDb data set, has only 1,000 numbers. So let us try to read that. Now, I am going to read this movies. Say a movies data frame. I'm going to create a movies data frame. So pd.read CSV. So this is my database name, or your dataset's name, CSV file. Then let us look at what should be the index column. So index column is the name, was the row name. So rank is 1, 2, 3. That is not a good thing. So we have made the title as the index column. So that let us run this thing and see how does it look like. Say, let us run this. Yeah, I have read it. Now, this contains thousand rows. So viewing 1000 rows is not a nice idea. So what I can do is we can run head command and read the first 5 or say 5 numbers, first 5 movies I am going to read. So now you see here the thing has come correctly. See, okay. So okay, let us examine the first one. First one is now your index column is your title. Index column is your title. So that was actually originally second column in the CSV. We took it as the title, or rows are named as against movies. So your Guardians of the Galaxy has rank 1. It's an adventure sci-fi. So here is a description. Here is a director. Here is the what? The other information, remaining information. If you move to the right, you will see. So this way, when you have millions of data, so typically the machine learning data sets will have millions of data. You will have to examine data like this. You will examine only a part of your data and find out ways to manipulate the entire thing via some kind of coding or program. So this also, I think in the last lecture we saw how to manipulate the head one. See, if you want to see only the first, you can put a head 2 or something. Run this. That will limit the number of things to the first 2. Okay. Similarly, you can view from the bottom also. You can view from bottom also. Say here that is movies.data tail will. There's a function called tail which will display the last 2. So this can also be very easily done. I mean, this is for viewing your data set. Now, when you have this you can run movies.info. This will give an idea about what kind of columns are. What are your columns? The first in this data frame, column 0 is rank. Column 1, that we are reading column wise, the other way around. So earlier we were looking at row wise, say 1 this way. Now we are looking at the column wise, how the columns look like. So column, this is the column 0 is rank. So let's see this is this one. So this is the column 1. So this one, the name we have made as an index column, and it doesn't count into the actual data. This is just a name indicator. Now the first thing is rank, then genre, everything is there. So now if you describe this, if you look at this way using info, if you movies.data frame.info, you will see here the column names. And the second one, and second column, you see 10,000, 1,000, and then suddenly against revenue, you see 872, and here against Metascore, you see only 936. This means these values are missing for some of the movies. So among the 1,000 movies, we have that revenue information of only 872 movies. We don't have information about the remaining maybe 168 or 128 movies. We don't have information about them. Remaining 128 movies, they in the data set, those values are missing. So you can examine a data set this way. How many are missing? So you can also the shape. I think I've covered it. Now another issue that you will find with data set is that there will be duplicate values. Even if you do a survey, if you manually entry data, at some point you will find duplicate values. And see, duplicates are cause unnecessary strain on you. They see you have to get rid of it. Now, see, we have this 1,000 values with us, so we will add some duplicates to it. We will add some duplicate values to the data set. and then we'll try to remove it. So for example, what I did here, what I'm going to show here is that, see, I am appending movies to, this is the data frame. So this data to this data frame, I am going to append or add some value. What I'm adding is that a copy of the original movies data frame itself. So that, and I appended a copy of the movies to the bottom and stored these values into a temp data frame. So this temp data frame contains your every row twice, because we have added it again to the bottom. So let us examine that. Run this and examine what is the shape. So now you have 2000 values. Let's say 1000 of them are duplicates. You can, okay. What you can do is you can do a drop duplicate line. See, it's very easy. If you have duplicate data, you can run drop duplicate, and then once you do a drop duplicate, say the duplicate values will be gone. But this is very valuable when you have when you capture real data. Okay, that is the idea of a drop duplicate. Now, many times you when you read data from this kind of files, see, your column titles may not be looking good. So I will try to manipulate the column titles now. So here, say you can view the index columns or the columns this manner: movies.df.index. So this is the current column titles for your movie data set. So suppose you want to rename some of them. Say for example here, runtime in minutes and runtime in million. I mean revenue in millions. These two things look a little awkward because there are a couple of brackets. You want to remove and make it a little bit more eye-catchy. So what I can do is you can movies.data rename. So what you are going to rename? Columns. These columns equal to these two columns. Then the runtime. In runtime in minutes, you are replacing with runtime. Runtime million. This again replacing with this particular string. And if you give an implies, if you give implies is equal to true, the original data set will be modified. Otherwise, you will get a copy of the data set only. Now, this way, if you run it, your revenue has been changed to this one. Revenue in millions. This has been changed to millions. So, but you can see there are other ideas also. You can even want everything to be capital. You can want everything to be maybe make it into first letter capital, or you can just do all these kind of things using say this way. Say I have replaced everything into something new values, or else you can run a lambda function or unnamed function here, some list iteration here, and do complete lower thing has been completely moved to upper. So this kind of possibilities are there. All kind of list comprehensions or things you can do. So I'm not detailing, but the possibilities are there. Now, so as I told you earlier, some of the values were missing here. So we will find out what are the missing values and then replace it. So one easy way to find out which is which column is which entry is null or not having any value. So that is very easy. So you can get rid of columns or rows with null values or the missing values you can do. Otherwise, you can replace such missing values with some non-value. So these are the two things we are going to see. First we are going to remove the unknown values or null values, and then we will, if the null values, we will substitute with something else. The first thing you can do is you do movies.df. So this is a data frame is null, whether this is, so it will check every entry for whether value is high, is the value exists or not. So when you do that, you will get this kind of a big table like this. So every movie, against every movie, if there is a some value missing, that will give you a true here. If the fortunately everything is the first values for the one shown here are all false. That is, there are no missing values. If there is some missing value, say it will show as true here in that particular column. Now, once you can even further do one more thing. Once you have done the true or false thing, you tested whether there is a null value, you will get back a data frame with the null binary values, true or false, as shown here. Here you can sum up column wise. Then you can sum up column wise and find out how many are missing, how many trues are there. So this is what I have done. I took movie data set. I found out whether there is a null value, and then summed up the entire thing. Column wise. So let me run it. Now you see that there are no missing values for rank, genre, or this. For revenue in millions, 128 things are missing. For Metascore, 64 things are missing. So this way, you can find out a null value. Now, if you want to drop all those with null, it is very easy. You can drop null, drop these values, drop na will drop. So those values. So let us run it and see what is the size of this. Here. So the resulting thing has 838 rows, 11 columns. So those with null values has been removed. So this way, if you have 1 million data, you can simply drop those null values. Say if you have 1 million or 1 billion data available with you, and you have only a few things missing here and there, you need not examine everything. You can just run this code and remove the unnecessary thing. Now you can even do further things on removal. So you can do other things like better options you have. Okay. Now in the next section, I will show how you can replace these values. So maybe if some value is missing, a small one value is missing, the remaining values may be useful for it. But with a missing value, you cannot do computation. So for that, we will replace the missing value with some value. Maybe you can replace the missing value with the median or average value of that particular column. So there are many possibilities. And data scientists do many kind of data fitting, so that they take nearby values. Maybe in this particular case, say you can take all movies of the same director and say take an average, and that will be the case. So maybe this is true for your Vijay movies, no? Vijay movies will have a same pattern, and they will have similar kind of story or thing. So it doesn't matter whether it is so whether some value is missing, you cannot easily replace. Okay. So this is how we have so let us look at that. So there are some missing revenue values. So let us look at that series alone. So I have taken the revenue in millions from the movie data set alone into revenue. Say, see this. Then okay, what happened? I think I made some error in the earlier place. So okay, so that alone, then if I print that revenue, alone, I will get something like this. I will get something like that for each movie. The revenue was this. So there are 1,000 ones, and this one is the real. Now maybe this one is the first value. Right? You can compute the mean. You can compute the mean of this particular value. So we will replace the missing one with the mean value. So here is the mean value. So revenue. So this is what you will do. People will do this. What people will do if you want to replace the some missing value with the mean value of a particular column. So you see, revenue fill null with the revenue mean. So that I have already computed earlier computed. So wherever there is a null value, that will be replaced. All null values with the. So now if you compute the null value, that something which I computed earlier, this has gone to 0. Similarly, you can do the same thing for Metascore also. Okay. Now the other things that you should know is that you can compute the various statistics for your variables in this manner. All numerical values can be computed using describe. Maybe you can compute several things from this. So you can even compute correlation between variables. You can. So here I have computed correlation between variables, whether runtime has any effect on the revenue. See, whether smaller movies, say, if you see here, a runtime and versus revenue. So that is a positive correlation. So rating versus something. So actor versus this particular actor has good movies, or this kind of studies, statistical studies, you can do on your data. Okay. Now this also I think I will quickly go ahead and wind it up. So you can take data, extract data. You can extract data from column wise like this way. You can give a column name here, or you can even give multiple columns, and take a subset of values this manner. And maybe by rows there are two ways. This log and ilog. This I think both we have seen earlier. See, if you say a particular movie, this one here. Say this will just display for Prometheus alone. So on the other hand, you can do look at the first one and do this way also. Or else you can give a list of values. So from Prometheus to Zing, you can list all values from this particular column to this particular row to this particular row. This way, more or less, it's similar to your list selections. Okay. Now you have a lot of other possibilities. You can try out. I will upload these slides. You can try out some of them. Now you can apply functions. You can do a little bit of this. I think we will look at in the concluding class. The next lecture, I will conclude with some more topics from this one and move ahead with our conclusion. Okay. So I think we will wind up our lecture series by next class. So I will give you some more ideas about pandas, and then some of the missing topics. I think small topics I have missed here and there that you can give. We can discuss, and then finally maybe the announcements like series exams or internals, etc. I will make. Okay. Thank you. We will stop now.